Hey everybody, welcome back. Today we're going to work on area of circles, but I want to show how other shapes also compare to kind of where the area of a circle comes from, how you figure it out a little bit, okay? So if I looked at this picture right here, what it's asking me to do is to estimate the field's area. It's saying it's set in a square, estimate the area. So if this is 800, that means this is 800, right? So if I found the area of the square, it's got to be a little bit less. So if these are my choices down here, 5,000, 50,000, 500,000, 5 million, 50 million, I can kind of get in the right ballpark. So if I did 800 times 800 base times height, remember if you have zeros, you would just do 8 times 8 is 64. Okay, I have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. Okay, so the area of the square is 640,000. My choices would be, and I can see that the circle doesn't take up the whole square. Okay, it takes up a good chunk of it though. So if my choices were 5,000, that doesn't make sense. That's not close enough. 50,000 isn't close enough. 500,000 looks pretty good to me. Okay. 5 million would be too big. That'd be bigger than the area of the square. And 50 million would be bigger than the area of the square, okay? So just using a little bit of what we already know, I can kind of estimate somewhere around where that would be, okay? So that's just showing you that, you know, if I'm given choices, I could figure it out without actually doing the math on that part. All right, this page we're not gonna do. We're gonna go into 8.3. This is kind of cool. So it's saying that, okay? And I'm gonna give you the formula for circle in a second. It says, imagine a circle made of rings that can bend but not stretch, okay? Kind of like rubber bands, but they don't stretch. So here's your circle with rings in it. It's saying, okay, I'm gonna cut this like right here and I'm gonna unfold it. This is what it would look like, which is really cool because what is that shape? That shape is a triangle, okay? So that kind of shows you that the circle formula must come from somewhat of the shape it makes. In this case, it could be a triangle. Okay? I'm trying to find the right lesson in my book. I did math problems. Okay, so obviously it represents a triangle, or it looks like a triangle. So how does the area of the polygon compare to the area of a circle? All right, well, let's figure this out. If I looked at the outside of a circle, we know that the outside of a circle, which would be this part, okay, is a pi times your diameter, okay? So this part would be diameter times pi, okay? So that would be the triangle. That would be the base of the triangle. So if I wanted to know the height of the triangle, that means I'd be going from the center all the way out, which is a radius. Does that make sense? And then a triangle formula, remember triangle is base times height divided by 2. So if I divided this by 2, I get diameter times pi times radius divided by 2. Okay, so there's a lot to this. So let's look at this diameter. If I have 2 diameters, 2 radiuses is 1 diameter. Everybody agree with me? 2 radius is equal to 1 diameter. So if I took this and said 2 times r times pi times r, okay? All I did is take this formula divided by 2. All I did is substitute, instead of diameter, I put 2 radiuses in because 2 radiuses make 1 diameter. All right, I can cross reduce here, which in this case, I can cross reduce the 2's. So I'm left with radius times pi times radius. What do you do when you have 2 numbers times each other or themselves? So this would be radius squared okay? Because radius times radius, 3 times 3 is 9, so radius squared times pi. So the area of a circle is, the way you write it is pi times your radius squared, okay? That formula came from that triangle, base times height, okay? This is the formula you're going to have to know, pi times the radius squared, okay? So it's pretty cool. It comes from, I can find a circle from using a triangle formula, okay? So if I wanted to find the area of the polygon, right, polygon, I would have done base times height. Base times height, okay? So what I did here is I said, well, I know my base would be, if I unravel that circle, it would have been the circumference. So I'm just going to go through it one more time, which is your diameter times pi times my height, which would have been the height that it takes to get to the inside of the circle. And I would have divided by 2. Base times, I forgot my divide by 2 there. Base times height divided by 2. All I did is say, well, my base is really the circumference. Okay? My step 2, so I'm just going to go through it a little bit slower, is I said, well, I do know that 1 diameter is equal to 2 radiuses. So radius plus radius gives me diameter. So I'm going to put in the 2 radius pi instead of diameter times pi times another radius, that was the height of the triangle, divided by 2. 2 divided by 2 is 1. R times R is R squared times pi. That's how I got the area formula. Okay, so it's pretty cool. Sorry, I have my paper up. So what you need to get out of this is to find the area of a circle. It is pi r squared. Okay, I'm going to write that really big. Pi times your radius squared. That's all there is to it. You take whatever the whatever the radius is, multiply it by pi, and you square it. Okay. On this one, so we're going to put it to use. Remember, we said the formula for the area of a circle is pi times your radius squared. Remember, radius squared, you got to follow order of operations. It says Elena wants to tile the top of a circular table. The diameter of the tabletop is 28 inches. She's not tiling around it, so she's got a circle tabletop. She wants to tile this whole thing, which would be area. What it's telling me in the directions is that the diameter is 28, which means the radius is 14. Right? Because 2 radiuses make 1 diameter. So I take my diameter divided by 2. Now I'm just going to put this into my formula. I'm going to take this radius and I'm going to say, well, the area of that circle is pi, we're going to use 3.14, times my radius squared times itself. I'm going to follow order of operations. I'm going to find a calculator first of all. I have to use my iPad because I don't own a calculator for some reason. I can't find one. All right, so if I did this, if I did my radius squared first, I would do 14 times 14. I'm sure there's a square button on here, but I don't know where it is. So I get 196 times 3.14. Remember, you have to do exponents first, and then I would just multiply that out. I take my 196 times 3.14, and I get the area is 615.44. Remember, area is always squared. Inches squared. Okay? All right, we're not going to do this part. So we're just going to do one more circle example so that we have it kind of down pat. Okay? Our lesson summary is right here, and it kind of gives you the formula for circumference, the formula for area. Remember, there's your area, there's your circumference. All right, we're just going to do a little example problem on this page. I'm just going to go back to this page. You can do it wherever. So let's say I have a circle, and I want to find the area of a circle. with a radius of 6, okay? So what I would do is I would say area is equal to pi times my radius squared, pi times 6 times 6 is 36. So I would do that first, then I would do the 3.14 times 36, which we're going to do right here, times 36, and I get 113.04. Let's say it was centimeters. I forgot to put a unit. That would be centimeters squared because all area is in squared units. Okay, so that's all there is to finding the area of a circle. You follow that formula. It's pi times your radius squared. Okay, pretty simple. That's all I got for you today. If you have any questions, again, let me know. See you later.